There are three mass points identical placed at the vertices of an equilateral triangle of side L. Question number 1, gravitational field. Number 2, gravitational potential at the centroid of the triangle. This is the equilateral triangle, side AB, BC, AC, all are L. Centroid is O. We get centroid by drawing perpendicular bisector. Equilateral, each angle is 60 degree. So half bisecting angle will be 30, 30, 30. All the three perpendicular bisectors meet at a point O. That O is called the centroid. For finding the effect of this mass at A at O, B at O, C at O, we need AO, BO, CO, which are equal. So taking this right triangle, BOD, cos 30, adjacent side BD by hypotenuse BO. Your aim is to find BO, so BO will be BD by cos 30. Cos 30 is same as sin 60, root 3 by 2. So BD is L by 2. BC is L, BD is L by 2. So L by 2 upon root 3 by 2 will be L by root 3 finally. Or if you already know the centroid is L by root 3 from each vertex, you can use that concept also. If you don't know yet to reach this point, we can learn this by heart directly. Each vertex to the centroid, the distance will be side by root 3. Now the first question, the gravitational field. Gravitational field is defined as gravitational force per unit mass. Force per unit mass, symbol is I. Gravitational force is gmm by r square by mass. So mass must get cancelled. G, the mass which is producing the field, by r square. Distance from the mass to the point. A, distance from mass to the point is AO. B, BO, C, CO. Important, it's a vector quantity. So always the direction of the gravitational field is due to the attraction of the mass. So it is towards the mass. Gravitational field of this mass at A is directed towards A. B is directed towards B. C, it is directed towards C. That's an important point. It's a vector quantity directed towards the respective masses. So the total gravitational field intensity at O is a sum of vector sum of at O due to mass at A, at O due to mass at B, and at O due to mass at C. So IO equal to IOA, IOB plus IOC. This is at O due to mass at A, at O due to mass at B, at O due to mass at C. If you just represent these quantities and measure each one separately, the masses are same, the distance also same. So all the three gravitational field intensities are same. IOA, IOB, IOC, all three are equal in magnitude, but different in direction towards each mass respectively. We're just writing a symbol I for representing the magnitude of IOA, IOB, IOC. You don't want to calculate because all values are same. It's a symbol I, only the directions are different. Now if you take IOA, it will be I but along positive j cap. These are the respective directions. They all are inclined at 120 degree. This is 60, this will be 120, this will be 60, this angle will be 120. You can get trigonometry with that value. Now this IOA is I j cap. The IOC and IOB both are equal and at 120 degree. You learn in vector addition a concept. Two equal vectors acting at 120 degree, the resultant will be same as one of the vector. For example, IOB, which is I, IOC, which is I, again, acting at 120 degree, the resultant again will be I, but the direction is minus j cap. So IOB plus IOC is same as I itself along negative j cap. It's a concept. Two equal vectors acting at 120 degree, the resultant is also same as one of the vectors along the bisector. Now, out of IOA, IOB, IOC, IOA is I along j cap, IOB plus IOC is again I along minus j cap. So those two are equal and opposite, they get cancelled. So the net gravitational field intensity at O is 0. For calculating the gravitational potential, you need to get an expression for gravitational potential first. The definition for gravitational potential is work done per unit mass. Potential is represented by V, work done per unit mass. We already learned in gravitation, work done is minus G mass 1 mass 2 by R. When you divide by mass, the second mass get cancelled, minus G, the mass which produces a potential, by the distance from that mass to the point, minus Gm by R. Importance is it's a scalar quantity. There is no direction involved. You can just add each potential. So the potential at O is sum of potential at O due to A, at O due to B, at O due to C, is substitute for each one, minus Gm by R. R is a distance from A to O for the first one, B to O for the second one, C to O, all three are same. All the three we already calculated as L by root 3. So L by root 3 comes common for all this. So Gm by L by root 3, this is just 3 times because there is no vector involved in that. So the root 3 will go on the numerator side, you get minus 3 root 3 Gm by L. It's an important point to take care of the difference between vector for the gravitational field intensity, because force per unit mass, force a vector, work done per unit mass, where work done is a scalar, gravitational potential also a scalar quantity.